Hey everybody, Dr. A here, and in this video we are going to begin our discussion of matrices. So the title of this video is Introduction to Matrices. So what is a matrix? Well, a matrix is a rectangular array of values encased in brackets. Okay, so an M by N matrix has M number of rows and N number of columns. All right, so that's the basic definition of a matrix. And another thing to note is the word matrix is a singular term. The word matrices is plural, so make sure we know that matrix is one of them, and matrices is two or more of these things. Okay, so let's go ahead and draw an example of what a matrix looks like. Okay, so for example, matrix A is expressed as the following. So here I'm going to draw an example of a matrix that I'm going to call A. I'm going to say A equals, and I'm opening up a big bracket here, and I can close it off, big bracket. So that's what we mean by an array of values encased in brackets. Okay, and again, it's an array of values, so we're going to organize the entries of the matrix like so. We're going to have an entry, I'm going to call it A sub 1, 1. And then to the right of that, I'm going to have an entry called A sub 1, 2. And then that can go on for however many entries I have all the way to A sub 1n. Okay, now don't panic if the labeling here seems a little overwhelming to you. It's okay, I'm going to explain it in just a second, so stay with me. So this is representing the first row of matrix A. All right, now let's go to the second row. The second row of entries would look something like this. A sub 2, 1, A sub 2, 2, dot, 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 all the way to A sub 2n. So again, this represents the second row of entries of matrix A. Now, we can have several of these rows. So I'm going to put dot, 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 meaning that we can have more of these rows of entries as we move down. Okay, so we can put a dot, dot, dot here and a dot, dot, dot here, all the way to the last row. So our last row of entries would be designated as A sub M1, A sub M2, dot, 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 A sub Mn. Okay, so let's take a look at what we have here. We have this rectangular set of brackets. Okay, this set of brackets with this array of values inside or encased in those brackets. We have row 1 here. We have row 2 here, and then you can have more and more rows all the way down to the last row here, okay? So let's make a note here. This is right here, this is row 1. This right here is row 2. And then this right here, we're going to call it not only the last row, but it's called row M, okay? So what we can notice here is the first subscript in each of these entries is the row designation, okay? So the first subscript represents the row designation. And so we can put a little note here. We can say we have M rows. There are M number of rows, okay? Now let's do something similar, but vertically. Vertically would be the column designations, okay? So right here, this is column 1. Here is column 2, and here is what we call column N, okay, column N. And so all together, we have N number of columns. So when we look at the entries and we specifically look at these subscripts, the second number that's in the subscript represents the column designation. So for example, A11 represents a value or a number in row 1 and column 1. For example, A22 represents some value in the second row and the second column. And then all the way here in the bottom right corner, AMN represents some number or value that is in the M row and the N column, okay? So that's how we think about it. So let's go ahead and be a little bit more specific on describing these labels, okay? And entry A sub ij represents a number in the ith row and jth column of a matrix, okay? And so the subscript I is what we call the row subscript. And then the second subscript, which we're going to generally designate as J, represents the column subscript. So this is just a generalization of the labeling. All right. So let's look at a couple of quick examples of different size matrices. Okay. So let's write this down. Let's say example, and then we're going to say given. And then the given information, we're going to say for the following matrices, state their size and identify each entry. Okay, so let's look at A. We're going to say part A. We're going to have a matrix with just a single number in it. Let's call it 2. And then in B, we're going to have a matrix with some other numbers here. Okay, and then matrix C, or part C, we'll have a matrix that looks something like this. So under solution, let's complete this example. So for each of the following matrices, state their size and identify each entry. So let's look at A first, okay? What is the size of matrix A? Well, the size is a 1 by 1 matrix. The reason why it's a 1 by 1 is because you only have one entry here, and so that means you only have one row and one column, okay? So that if you have a matrix with just a single number, that number occupies the first row and the first column. So that's a 1 by 1 matrix, and then you can say its entry is A11 equals the number 2. If we call it matrix A, for example, its only one and only entry is the 1, 1 entry, and it's the number 2, okay? Let's jump to the second matrix, okay? What is the size of the matrix in part B? Well, again, the size is always going to be the number of rows by the number of columns, okay? So how many rows do we have? Well, we've got 1 row, 2 rows, 3 rows, and then we have how many columns? 2 columns. Columns are vertical, right? So you have 1 column and then you have a second column. So the size here is a 3 by 2. Always remember the size is the number of rows first. List the number of rows first and then the number of columns second, okay? And so if we look at these entries, the 1, 1 entry is the number 1. And then what about the entry of the first row but of the second column? You would designate that as A12. because you're still in row 1, but you're in column 2. So what's that going to be? That's going to be the number 2 here, okay? Number 2. And then let's go to A21. Again, A21 is the second row, first column. Second row, first column, that's our number pi here. And then A22 is going to be Euler's number E. A31 is the number 0, and A32 is the number -1, okay? So make sure you can follow along and identify all those entries. So let's go to the last part, part C. The size of this matrix is what? Well, the size here is a 1 by 4. How do I know that? Well, again, you have one row and you have 4 columns. Each of these entries represents a different column, okay? One row and then 4 columns. 1, 2, 3, 4, okay? So again, you got row by column, and so that's why it's a 1 by 4. And then, of course, the A11 entry is 1. The A12 entry is -3. A13 is 0. And A14 is 0.5, okay? So maybe pause the video, take a second, and make sure you know what you're looking at here and you know what each of these entries means, okay, and why they're labeled as such. And always remember, the size of a matrix is going to be number of rows by the number of columns. Rows are horizontal, columns are vertical, okay? So that's going to conclude this video. I hope you liked it. Please hit like and subscribe.